Hi guys, welcome to Learn Electronics Repair. This video is sponsored by PCB and we are going to have a look at more advanced use of Easy EDA. I made two beginners tutorials on Easy EDA which show you how you could very easily design your own electronics projects and create PCBs which you can then order from PCBWay.com. To assist me with this video, I invited my friend Detlef to show us how to use Easy EDA and how and why we should manually route our PCBs. Okay, let's have a look.
Going for should save this. Yeah.
Yep, save.
Yeah, guys, remember one thing: always hit Control S for saving this stuff because you don't want to lose this. This was too much work right now to lose this. Control S is your friend. Okay, we want to do a PCB here, so this is pretty easy in Easy EDA. You can simply go up here. There's a button for this. I don't know what the symbol should say, but it says convert schematic to PCB. So here we go. I don't want to check nets because I know I have some nets over here. These are these things over here. We didn't put the axis on it. This is not important. Simply keep going.
These are the unused pins on the USB. We're only using it for power.
Right. Yeah. We only need the power pins, so we didn't use that. Now I do something different as some people do because I'm not sure how big the PCB is going to be. So I don't care about the rectangle size right now. I simply go cancel because I don't want to have this. And in fact, I'm going to trash this thing here. This is board outlines. I don't use them. Right now, I don't use them because I don't know how much my stuff will go.
That makes sense,
to be. Yeah. So I'll want to mess around with the component placing right now. I think we do this in a fast forward again because this is something where you simply put your stuff and we could use a reference as a reference. We could use the original.
We could use the original,
yeah. But I think I want to go for that and simply try out how is it going to be.
Okay.
Look at this. We choose the wrong footprint for the pot.
We can mention that.
Yeah.
But we've just noticed we have the wrong footprint for the pot. We could change that.
Yeah, we could change it. Yeah, but would you be fine with a pot like that?
Yeah, we can get pots like that. That's like a trimmer type pot.
Yeah.
Yeah, we can do it.
Yeah. And for a compact design, I would prefer those.
But we'd actually need an adjustable pot, but that's like a compact adjustable
I think I brought some with me.
Okay, that's nice. Okay, we can use them. We can use them, guys.
Okay.
And Death rescued us there, yeah?
Okay, let's zoom in a bit. Of course, we start with the connector. On my connectors, I never need the names here. So I simply can go for a display prefix, display name. I simply go for no because I know this is a connector.
Yeah, sure.
I don't care about that. So I want to have this to my, this is R for rotate. I simply want to have this to my left side of the board. Somewhere there. This is my starting point right now. I don't know where I'm going with that. This is something I have to put on the rest of the board. What else do we have? The Q1 would be important that we have this somewhere, right?
Well, in actual fact, we're actually going to mount the Q1 off the board. Because we're going to use a separate heatsink, so it doesn't really matter where you put it. We're going to actually use that as terminal, so near the edge of the board somewhere.
Yeah, somewhere around the edge. I move it out of the way because right now I don't need it. This is a personal preference. Do you need the Q1, so the component name and the type of the thing on your board?
I would usually leave that on the board because it's easy if people order these PCBs when.
You're right.
Yes.
Yeah.
So I would leave them on.
Yeah. So we also should leave the what is it on the board? Yeah.
Absolutely, and the values of the resistors.
Yeah. There's actually no rule for that.
No.
Sometimes when you have a very tight packed PCB, there's simply no room to leave the markings on there. This one would be we have enough space in here. I personally sometimes simply leave the component names off because if I put the values into a resistor like this, for example, it's already there. I don't need the R5s.
Strangely enough, I tend to use the other method, which is because if you leave the component numbers on, it's easy to refer to the PCB if it doesn't work.
Yeah, that's true.
So that's my opinion. I always actually put the value of the resistors in the middle of the symbol.
That was
the number by the side of it.
That was what would I do? That's what I was going to do next. Yeah. So I grab all my resistors, move them over here. Why do I do this will be clear in a sec.
Okay.
Because now I can select them all. and simply say, okay, I want to have my names in here.
Excellent. And then we can move the values to the center of the...
Right. And now you can click the values by itself.
Yeah.
Sometimes it works. Right now.
Click it.
Yeah, this
it's
is
because they're all selected.
Yeah, this is a bit fiddly. Oh, they're still selected. No, they're not anymore. Well, anyways, simply do that. Let's do this like that. So now we have a builder's friendly board because all your values are already in the right position.
Yeah, exactly.
Yeah.
You're not too worried about straightening them up at the moment. We'll do that automatically.
No. This is done later.
Okay.
Because now we're just making the board, making the components pretty.
Okay.
We can do the same with the capacitors. With the caps, right there. Why do I group them? Sometimes if you put in the IC for that, you don't get the correct object properties over here. And if I sort them by what it is, I always get them right.
Okay. So display date. Yes. We have the values.
I have the 100 nano in here. There's the 10 nano. 100 nano.
Okay.
Yeah. Same, of course, for the IC. ICs have so much space.
This IC is actually LM358.
Yep. Got it in here.
Okay, you have it.
I could leave this outside.
Okay.
If you prefer.
I'm easy.
So we need the one.
Which is the TL431, yes.
Yeah. That was, by the way, this was the reason why I was typing in the names. You know, there was this long letter combination.
And you made them short.
TL434 blah, 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 for half a mile.
Yeah.
And that's why I shorted them out, because this works on a board.
Okay, so the SMD resistor is 050 or 050 is the value.
Yeah. Right, and 50 milliohms.
50 milliohms, perfect.
We can put it under there.
That's fine.
That will work, yeah. And the pot has a value to it. It's a 10K. So this goes in here.
Okay.
So we don't need anything on the connector because this is connected.
Yeah.
I think everybody can see that this is connected.
So we need the pot on one end so we can adjust it, sticking out at the back.
Okay.
And I would put the TIP 122 at one side.
Mm-hmm. When you move them, you actually see where it's connected to the rest of the wheel.
Yes.
So we know this TL413 goes somewhere over here. That would work pretty well. What I'm looking for right now is less crossings, as less crossings as possible, because every crossing is bad.
It's a fire.
Yeah. So let's rotate this until I can live with that.
Okay.
Is it okay for the spacing for you?
Yes.
Good. I'm not sure if we keep this direction. Maybe we'll put it vertically.
I would think you probably would put it, but anyway, you go for it.
Yeah. So now this goes over here. So I can heat. I'm not going for any rasterizing right now.
What's rasterizing?
You can adjust where's the component to the board. And so you see the raster over here.
Oh, okay.
I'm not doing this right now. Maybe we should. I'm not sure yet. Let me play around with that.
Okay. Then we'll speed this up.
Yeah, I think so. Yeah. So, oh crap! Sometimes you grab the.
Yeah, you grab the outline, don't you?
Yeah.
I figured that out myself. You just grab the outline.
Happens to me all the time. All right, this goes somewhere here. Let's go there. This is everything for the for the Darlington.
Mm-hmm.
Oh, look at this. This goes over here.
So we put the Darlington somewhere near the edge of the board, like it was on this one. Then I can easily put tracks on, put them external.
That's even better workable.
Rather than being at the back, it can be at the side somewhere.
Yeah, look at this. This seems to be pretty much at home over here. Oh, no. I can go over here and over there. That will work.
It says all three upside down. What's that green dot? Oh, yeah, it was your cursor.
So I can bring this up here, move this down here.
So that's kind of crossing from there to there, isn't it?
Yeah, that's not. I can go over here.
But this goes the other way anyway.
I can go over here. I can use the line outside. and this is straight anyways.
Yeah.
So then I have a nice connection over here.
Okay.
This will change. This will change while we do.
As we're working, it will change.
Yeah. So this side over here, somewhere here, there's a cap coming in. This cap goes. Okay. Is this ground? Probably this is ground. Yeah. This will be ground. So this will be coming right from the USB plug. So I can go somewhere here with that. These are gigantic.
Doesn't matter.
Footprints. Yeah. So. Too big isn't a problem in here.
No.
But
easy for people to put together.
yeah, you're right. So why I'm going to do this like that, because I have one straight line.
Yeah.
This is easier to route than.
Yeah.
And this one is moving somewhere here. This is going over to the. All right, and now see, this is what. These are the lines that go through all the shenanigans over here. R1 probably belongs here. R0. Yep. Just
Yeah, you want the current sensor resistor close to the power transistor.
Sure. So I'm not sure where you guys are going to go. Oh, I see. You want to go there. This is a noise. This noise filter. I can. Yeah, I know what to do. We simply move those a bit down. I'm starting to see a line here.
Okay.
And I want to have components like these. Rotate over here. Move the number somewhere else. Rotate. I want to have C2 not on the top here, because we want to keep the board a bit shorter. So now I can move on.
Grab that one.
Yeah. Now I can move this one in.
I
want to go here. Move this one in. This is easy.
Upside down.
Yeah. I can do that. To rotate. Now it's getting tighter. So, you, my friend, come over here.
That one's probably going to be sideways because of routing the wires off the board to the heatsink.
This is okay when we move the wires to the back. So we'll keep this design. Okay. Let's move this over here.
Then I can come down and sideways.
Let's
down.
Get this down here.
Yeah, so somewhere with its current. Yes,
this is on the side of the PCB right now.
Somewhere with its current sense resistor. That needs to be close, obviously.
Through this over here. We need that somewhere here.
Yeah, that's fine. And this sticks on at the back end of it.
And this
rotating.
It's okay. I'm not a huge fan, but this is good. There's a short track over here, and something like
that's the wrong way around. Actual fact, because the middle, there should be more out of it. That's where your adjustment is here.
Yeah. Okay. So this would be the right way around.
Yeah, I think so.
I hope so. So now I can move my power in here. And there's my board. So this is the first version we came up with for the board. This is slightly smaller. Has all components on one side, I think. And what we're going to want to do in here is now it's going to for the tracing. And I know what you think. Autorouter. Never trust the autorouter.
I'm not sure I trust myself.
Autorouter in EasyEDA has an autorouter, and this is probably the best thing you can say about EasyEDA and the autorouter.
Yeah.
It has one.
Oh, I see. Okay, it has one.
It doesn't know about track width if you don't use a lot of information in here, and I think we can do this better and faster by foot.
Okay,
because we know what tracks we're going to need. We're actually going to use both sides.
Yeah.
And especially we're going to use both sides because of the current load on here. I don't want to have so much power loss on the tracks here.
Okay.
So let's
do it.
Go to it. Come to it.
Let's see then. How do we do it?
Okay. I think I start with what do I want to start?
Well, I guess the main current routes are the power and the ground, and then the circuit through the tip 122 and the current sense resistor. That's where all the power is.
So this will be our ground here. This will be with the ground net because.
Okay, that's the one that goes everywhere.
Yeah.
Yes, because it goes to pin 4 on the LM358, so that is ground.
To make this life easier for me, I simply switch off the devices because now I can only see the nets and where everything is going. And I go for wire. This is W I'm pressing right here. And I have lots of space left. So the routing with this is a thing I will play a lot with. So normally I go for, this is through hole. We have lots of space. So at least 20 mil.
Okay.
Mil, not millimeters. This is inches. It's imperial. Yeah, I know. And I'm from Germany. I use imperial here.
Yeah.
Because this is simply the pitch width. The pitch width is 0.0, 0.1, something.
Of an inch or of a centimeter?
Yeah, it's always an inch.
Oh, okay.
And in centimeters, 2.254, something. And it's way easier to do this in. Because all the PCB industry does this in
inches.
Inches. Yeah. Yeah, I'm living with that. Okay. So when I can, I use thick lines, thick traces, because I have the space in here.
Okay, so
the copper is anyways on the PCB, so I can use thick traces for everything I do here. And I starting with where I want to start. I think I want to start with the lower side, with the back side.
Okay.
Wire and simply go there. And this.
Oh, I see. That shows you where else you need to go.
Yeah. And you see how much space I have left.
Yes.
These pads are so big.
Okay.
And talking about big pads, we could do something before we start layout.
Okay.
These are okay. These are okay for normal work, but we have so much space left. We could make nicer pads. What do you think?
If you think they should be changed.
Yeah. I normally do this if I want to do a nice PCB. Because this is okay if you want to put stuff in, but I have the opportunity here to use an oval part.
Okay.
And I can go for let's see what's what. This is never the right way around. Let's see. Yeah.
Okay. Oh yeah.
Look at this.
Yeah.
So now you have way more copper over here to solder on.
Okay.
This makes life again easier.
Yeah.
Yeah. You can do the same with all the resistors. You simply click on the parts you want to change. I'm holding control right now. This is the cap. This is the cap over here. And give them bigger parts too. So what we have right now is 55 mil width and height. This is rounded pad. If I go to, say, 65, it doesn't kill me, but makes soldering easier.
Okay.
I can do the same with this is the TL431.
Yes.
Yeah. I'll skip the squared one. I'll simply go for, I want to have an oval one here. And this should be, say, 90.
Okay.
So now I have way more copper over here.
Okay.
So this should make soldering way more easy, especially if you're not that experienced.
Okay. Yeah, that makes sense.
Yeah. Okay. Let's drop some wires on here. Tracks. I'm going everywhere. I'm all over the place right now.
Okay.
This is a 20 mil track here. You can click on it, and it tells you 20 mil over here. We can use a bigger one.
Okay.
We can easily go for 30 mil.
Okay.
This starts to feel like a track that should be there.
Okay.
So I'll go for, when I start layouting right now, it already took the 30 mil I just used and uses this as my new starting ground. So I simply start to route away. What I'm doing right here, I'm clicking once, and I don't want this. I want to have a straight connection over here. So I have to change the direction of the track. This is R. So now the track splits over here and connects over here. So even if I don't have any raster here, this is a straight connection. So let's keep going for that.
Okay.
That should be easy. No, you see.
Oh, I see in the holes it's actually telling you what the nets are.
Yeah, it does. So these are nice traces. This is easy to solder. This is so easy to solder. Everybody can do this.
Good.
So So there's a GND, there's a ground connection. I'm actually not putting anything under the chip right now because I'm not sure if what traces I will need there. I will for sure need to do that one here.
Okay.
So let's go down here, change the direction by pressing R. Now I stay out of the angle here. Click once, connect it here, and click twice.
Okay.
So these are straight lines from the part.
Okay.
Ground over here, click once, click two. So nice tracks over here. This is a connection. I can simply go there. I can simply go. This is a connection over here. So go there.
And it show you where they go to?
Yeah, it
when
does.
you click on them?
It does, yeah. See the white line where I'm hanging it in?
Yeah.
So it tells me go there. I don't have to have the circuit diagram in the back of my head right now. I want to have a straight line over here. Go there, go there.
You want three the same.
Something over here, so that's easy.
Yeah.
Yeah. The ground plane we'll put on the other side.
Okay.
So just starting to look like a PCB.
Oh, it is. It is actually, Det. No, you're right, Det. It is.
All right. VCC will have lots of power over here. So this is the control side. Let's say this is the control side. Let's declare the upper side for the power side, so we can use even thicker tracks on the upper side.
Okay. Well, they're mainly the thicker tracks from the USB to the transistor, yeah. And the
That's mainly my thing in here.
Yeah.
Because we need to. This supplies the op amp and stuff.
Yeah.
So this is the.
Although not so much current is flowing that way.
Yeah. This is the thick tracks over here are just for comfort.
Okay.
We can use them. There's no reason not to.
No, it's fine.
Yeah. I'm going over here, going there. So I have my GND over here right now. Move this somewhere there and there. Where's GND? Okay, there's GND needed over here. I can come from here, go there. Change direction, R. Okay. There's not much left. There's not much left.
That's quite a lot to me.
No, not really. There's some tracks here I can simply throw in here. So like this. Like here, this goes. Oh, come on. I just hit the wrong space for that one, so it wasn't happy with that. I want to go diagonal here, something like that. Yeah, this is okay.
Okay.
If I want to move this, this is something I think the clearance here could be better because I have much space. I simply can click on this line, move it a bit down.
Oh yeah.
So that's in the middle.
Yeah. Better.
Yeah. Right. This one is needed over here, so we simply go wire. This is a bit close, so I won't go with my 30 mils here. I go for say 20.
Yeah, thin one.
Keep in mind, 20 mils is absolutely fine. You never need that much current you can use on here. So this is simply for convenience. If you're etching your PCBs yourself, you can do this. A thicker line is even better because you remember the days with
etching solution.
Ferric
chloride.
That was horrible. But if you use a laser printer for that, for example, and you have a very very thin line, the chances are your line isn't connecting.
It's going to go away. Yeah.
And this way you have more copper on that one.
So does this need a wire to get into that place or not?
No, look at this. We simply go here, we go here, we go. Not happy with that. Happy with that.
Okay.
I know this isn't coming in square, but the clearance here is massive.
Okay. Okay.
Yeah. You see, I'm not using much wires in here because I simply don't need one.
This is the current sense.
This is the SMD
ground.
the SMD thing magic. We have this on top. So
You have it on top at the moment, yeah.
yeah. So we have to go for the top layer because this is where a component is when we need to connect here.
Okay.
So there will be power on this.
Yes.
Yeah. First, I want to change the style of the pads over here.
Okay.
This is our power transistor. So
Yeah.
that's where the power is.
Okay.
I want to have oval pads. Oval, come on.
Uh-huh.
Want to have, don't know, 120.
Mm-hmm.
Oh, this is the wrong direction.
Okay.
See, guys, that's how you make errors.
Uh-huh.
Keep it, say, 75 mils
Okay.
by 120.
Okay. Oh, okay.
I can even go bigger. You can go 150. These are pads you can solder on.
Yeah.
You know, lots of wire.
Okay. Good.
Yeah, on your board you used wire, right?
I use wire with
Yeah.
to external transistor.
Do you want to have bigger through holes? Because you can
I
enlarge
think on
them.
this version we're okay for that because we're going to make some modifications to this.
Yeah.
We can get some PCBs and then we can decide.
Yeah, iterations.
Yeah.
Yeah. All right. So I keep this that way because that will work anyway because you can solder anything to that.
Mm-hmm.
So I now selected the top layer and go for wire again, and I know this trace will carry a lot of current.
Yeah.
So I'll choose anything I can get. I go for 40 mils right now.
Yeah.
Wire. I want to come out straight, so arm. Go there. Go there.
Okay.
That trace will work.
Okay. Good.
If you want to transport more current over here, yeah, you simply can go do the same track on the other side.
Have a double-sided
and
track.
use some wires in there.
Yeah.
This would transport heat, and it would give it even better conductivity. So after here,
This is ground.
this is ground. Yeah, ground. I think we come in on the other side. We have to come on the other side. I think this is VCC. Oh, we need fat wires for that. Do this on the top. We can do this on the top layer right now. Come
Okay.
on. So wire. Yeah, I can do this. So I can go. I need to go over there. This is VCC.
Okay.
I will use this one here. Go there. Remember, this is top layer, so I can.
So you can cross over the blue lines.
You can cross the blue lines right now. I don't want to connect here because I want to connect right at the source, and the source is there.
Yeah.
So now I have this track here that transports all the current I can get here. I can even make this a bit bit thicker because we have the space.
Yes.
50 mil.
Okay.
This is nearly the size of the pad itself.
Yes.
So there's enough current in there. So go
So we
over
need
here.
to get this to the transistor. Yeah.
Change the direction. Go over here. Go over here and connect over here.
Okay. Yeah.
This will carry some power. Yeah.
So the last heavy current path is from the ground of the current sense resistor
Right.
to ground.
And this is going over here. Right.
Yeah.
I think we used a flood fill for that on the other side.
Okay.
I'll show you this later. Let's keep this open for now.
Okay.
And what want to do? There's some things to do on the other side. Go back to the bottom layer. Go for wire and go back to some reasonable sizes.
Okay.
I'm going for 30 right now. Wire. Oh, no, bottom
the wrong
side.
side.
Bottom side, my friend. Wire.
Okay.
Wire. Go over here. Go over here. Go there.
Mm-hmm.
This one won't carry any current. This is simply measuring.
Yes, correct.
Yeah. Oh, and I'm on the wrong side. You see, I can't connect here because the component is on the other side. Yeah. So I need the top layer. Wire. Go down there. Go down there.
Okay.
I could have used the wire through a wire in here, but since these components are on both sides anyway,
yes, exactly. So you didn't need another hole.
Yeah, yeah. So this is a long trace here. So I keep this for the moment. I think I want to do this one. This goes right around here.
Okay.
Wire. This is the base of the.
Yeah.
Can do this on the bottom side. Wire. Go over there.
Uh-huh.
Go over there. Go over there.
Okay.
Here's another one that needs to be on the top side because it connects to the...
Yeah.
Oh, it doesn't. It doesn't. It doesn't, my friend. Because we can do this. Wire. Oh, no, we can't. Yeah. Sometimes when you imagine that there wouldn't be a track.
Okay.
Now I have this. I need to get... This is a long one. This is a long one. Probably... Can I get out of here? Maybe on the top side.
Mm-hmm.
Yeah, on the top side. I can get... This is in the way on the top side. I can go over here.
Yep.
I don't want to have so much stuff going on over here because I want to have a small PCB here.
Yep.
And we have so much tracks over here. That is not the best idea. Can I do this better? Yeah, I can. Sorry, I have to kill a track.
Uh-huh.
Wire in 50 mil on the top side.
Uh-huh.
I want to go on the other side.
You're going around the outside.
Yeah. So right now I can go over here. I want to leave some space, some clearance in here.
Yeah.
And then I want to connect here.
Okay.
So now I have the space over here, so I can go move around.
Move around.
Yeah. I know the autorouter does this faster.
Yeah.
But look at these squiggly lines, man.
True. I thought AI was better than people at this sort of thing.
I'm waiting for that. I think AI is the thing to do auto routing. This will do so great.
Yeah.
This will cut down this problem away. But currently, auto routers, indeed, especially the one with EZDA, isn't that intelligent.
Okay.
To say it carefully. You probably would have right now. You would have a bunch of wires in here, anyways.
Yeah.
And this way we don't have any wires. Wires are, of course, they're technically easy, but if you don't need them, yeah, maybe I'm old school. All right, we have some space left on the top layer, so wire. These look so thin. This is a 20 mil trace.
Okay. For what we need, not much current in this.
Yeah, right. This is what you keep in mind, and this is something you have to teach the auto router the other way. How much current do I need for this?
Yeah.
So I want to come out here. I want to come out here. Somewhere here. Yep, that will work. And now I can connect to that.
You can't.
Okay.
You can.
Yeah.
You can. You have connected.
Don't scare me.
You have. You already have.
So this line here, I can go from here. Yeah, we can end up over here.
Okay.
Wire on the blue side, on the bottom side.
Okay.
Go here. Go here. Go here.
Okay.
To left, and one of them is ground, I think, for the one of them is ground for the this ground.
Well, this
It tells me what it is.
that's not the ground end of the current sense, is it?
No, this is simply a net. This isn't the ground side.
Is this a monitor for the current sense?
Yeah. This is ground.
Yeah. This is the monitor for the current sense to the op amp.
Yeah.
Goes to pin 2, I think you find on the op amp.
You're right. You're absolutely right.
Oh.
Okay, look at this. We can go here. We can go down here. Move this a bit out of the way.
Mm-hmm.
So now I have enough space to get away here. And this time I'm going to use a wire. On top. Go over here. I will put the wire under the resistor itself.
Okay.
Bottom.
Okay.
Yeah, I move out here, grab the wire, go onto bottom side and move over here. I probably could get away with some fiddling around here, but in this case, this is the easier way, and we know this track won't carry not much
No,
current.
so current sends to the op amp. In
Yeah.
fact, probably almost no current on that.
Yeah, indeed. Yeah, and this one is easy because we can do this on the top side.
Okay.
Wire. Go. Oh. Ah, crap. Sorry, I have to kill this.
Mm-hmm.
Wire. So, let me zoom out.
Can you tell that everything's already in place? Because it looks like there's nothing from here, goes just something. Oh, that's the end of a resistor.
Yeah, you're actually right.
that's-
We have to go make this connection, but I can skip this. All right. So this looks pretty much like a PCB, right?
Yeah.
Okay. I actually missed one over here,
Okay.
but I'll do this in a different way because
Okay.
what you always want to do on your PCB is, I do this all the time. You want to have a copper fill.
Yeah, copper fill, yeah.
Yeah, not only because it's good for temperature, it's good for connectivity. I think it's good for the environment because all the copper that's on the
It stays on the
F4
PCB.
stays on the. It doesn't get into the solution
Yeah,
that you
yeah,
use
yeah.
for etching. And I think copper fills should be mandatory.
Okay.
You can do this pretty easy in this one.
Mm-hmm.
There's a copper area too over here,
Uh-huh.
and you say, okay, I want to connect it to G&D.
Yeah.
And then just simply draw your area where you want to have a copper fill.
Okay.
But we do this another way around because before we do that, we want to have the outlines of the PCB.
Okay.
There's a thing to set baud outline automatic, but this won't work that well because we have this USB plug in here.
Okay.
Maybe we can get away if we do that. Let me try that. Advanced tools, set baud outline, rectangular, blah, blah, blah. Go. Okay, we get
Okay.
away with that. That was easy.
Okay. Okay.
Yeah. What I did right now, I deactivated the outline for the USB plug here.
Okay.
This is on layer document.
So you put it back in now.
Yeah. Because if it would stay on, the software would say,
Draw around the edge of it.
Yeah, would say,
Yeah.
okay, there's something left over here. I have to go there.
Yeah, yeah.
Yeah. So now we have a nice tight area around that. This
Mm-hmm.
is just as wide as our trucks are going.
Okay.
And now I can go for the copper area.
Okay.
Okay. And now I simply draw a white berth around that. There's no precision here. Simply go
Just around
wild.
it.
Yeah. This is a polygonics in
Yeah.
fact. So you can draw anywhere. And there's a fill.
And that's the ground fill.
That's a ground fill, right? You not only want to do this this is the top side. We won't go to the bottom side, and do the same again over here.
So we don't have a power on one side and ground on the other. It's all ground.
Not on this one.
Okay.
Not on this one. You could do that, but I want to have vias on here
Okay.
because you see. There's some space over here.
Okay.
And there's no direct connection here. Do you see?
Okay. Yeah.
So this is something. It's getting this ground from here.
Yeah.
We modify this a bit because there's a pain in the neck to solder if you keep it in the standard connections.
Okay.
Okay. I can select the ground plane over here. So now I have the ground plane on the thing here. The first thing I increase the clearance. The clearance is how much space do you have around the pads.
Okay. Oh yes.
Yeah,
Yes.
I want to have this a bit bigger. I go for 20 here, 20 mil.
Yeah, and there's more space there.
There's more space. So
And more space between the tracks
Yeah.
now. That looks better.
yeah, the heat that you put in here to solder this part is now very much more handleable. Same with the SMD component over here. And spokes is okay. You can select the spoke width. That's
Okay.
another thing. You go for 20 or 15.
Okay.
So now the spoke starts to look like they're usable.
Yes.
You can solder that without pumping 400 watts in there.
Okay. Okay.
And I do the same for the other side. This is sadly you have to do this for both sides. There's no automatic to say
Okay.
keep the setting over here. So I go for 20 mil. Spoke with 10, 20. So now we have a nice connection over here.
Ah.
Did I do this? Yeah, I did this on the other side. Yeah, you see this over here.
Okay.
So now my connection, I told you that I forgot the connection over here. You see the flat fill over here has made the connection anyways.
Okay,
You can even get away if you delete this one.
Because it's all on ground. It's
all ground.
Good.
Yeah, one more thing, and this is important for this one because we have this high current situation. You can select this one and go for add remove via over here.
Okay.
And we want to add this and go okay.
Oh, and it puts wires through. Yeah.
Right now, all these wires are interconnections between the two layers. That's why I wanted to have ground on both sides.
Oh, okay.
So we have a massive ground layer now. That's coming from over here. Mm-hmm. It's coming from both sides over here. So this is all ground, and since it's interconnected, this is all ground.
So that's exactly.
And our other side of the circuit
PCB,
is going over here. This has this
massive
track. This is a massive track over here.
Then what about the output from the tip onto two? Where's that going to?
This is that one, and this is going to ground over here.
Okay.
And our ground is this big massive track.
Okay, yeah. Can we actually, at this point, center the USB socket on the board, or can we not move it now?
We should have done this before.
Okay, we'll cut that then. We won't even talk about it. We'll rejig it before we order some.
Yeah. I actually didn't think about it.
Yeah, we'll do that later. So, then that PCB is ready to order.
This one is ready to order, yeah.
Okay.
So this is your part again.
That's my part. I'll put this onto PCB. So then, guys, there are a few other things we'd like to do with this project, and we'll go over to the. Hold on.
We should show them the preview.
Okay, guys. So this is a preview of the PCB. We can see how it looks. Looks nice. Yeah, happy with that. So I will now upload these files to PCBWay, and we can order these as our next version of this. So Det did say this was a job for me now, so let's create a Gerber file from our PCB and then order some prototypes from PCBWay.com. To create the Gerber file is actually very simple. We go to File, Generate PCB Fabrication File, Gerber, and I'll just tell it to check the rules to see if there are any problems. Well, it seems quite happy with that, so let's generate a Gerber. And I now have a Gerber file, which is a zip file. This is what I need to upload to PCBWay. I'll now go to PCBWay.com and I'll show you just how easy this is. Okay, so we're now on the instant quote page. I don't need to enter any details at all here. All I need to do is upload the Gerber file. Let's click on quote now. Okay, so quote now, and then the Gerber file. Quick order PCB. Okay, click on that, add Gerber file. We'll now find my file, which is this one. Open. And there we have it. I'll make a few very simple changes. In particular, one, I will change the PCBs to red because this is my channel color, if you like. So we'll have red PCBs. And then we can just go to the cart. So the price of our PCBs is $5. And you'll see I actually have an express shipping, which is $25. If I wanted these quickly, that's fine. I'm actually going to change the country because I'm not in the USA. So I'm going to change this to my country, which is Spain. And I have all these various options for delivery. I'm not in any rush to get these, to be quite honest. I'll take standard global shipping, which is $4, 9 to 13 business days. That's fine for me. It's actually the cheapest option on here. So we'll go with that one. Apply. And we now have the total. So my 5 PCBs will be a total of $9. Later, I will just save this to my cart. So I will log in on my account and I will order the PCBs so we can try them when they arrive. But guys, It's as simple as that if you want to order PCBs from PCBWay.com, and you can see that's a very attractive price. That's less than $2 each for 5 PCBs. I hope you found that interesting and you feel confident now to design and order your own PCBs, either using the autorouter, which would do a lot of that work for you, or following our method, or should I say Detlef's method, which produces a far more usable PCB. I'd just like to thank once again Detlef Amend for his assistance in this video. You'll be seeing a lot more of Detlef, and I will also say Carlos from Meter Upgrade and myself with a special collaboration we're working on. And lastly, I would like to thank PCBWay.com for their kind sponsorship of Learn Electronics Repair. I look forward to seeing you all soon on another electronics repair video. Ciao for now, guys.